Bad boy. This is any math person. Hi. Oh, okay. Thank you. This one doesn't say like this. This one, you know, if this one's in the this doesn't say anything. Oh, that's it. That's okay. All right. Here we go. All right. So this is kind of the wordy version of the second derivative test. Sorry, of the product rule. First times the derivative of the second plus second times the derivative of the first. Here we go. So if, first of all, please constantly pay attention to notation, okay? If I see this on your paper, I just can't even explain to you how terrible that is in terms of calculus. You just got floating stuff with no labels on it. What's the original? What's the derivative? You've got to label your work, I beg you. On the AP test, the first point is often for finds the derivative. And they will not interpret it for you. If you don't have it labeled as the derivative, you're out. Okay? You have to say this is the derivative. So please, notation. Dy dx if you like, or y prime, either way, but for Pete's sake, please give me, this is my derivative, Mr. Rickman. Here it is. You can find it now. First stays the same. Derivative of the second. Plus second stays the same. What's the derivative of x? 1, okay? Anytime they ask you to evaluate at a point, it should be a two-part process. First, I'll show you the general derivative, then I'll put the number in. You will not, again, get full credit if you do those at once. You do the derivative and put the number in. That's a no-no. You don't do that. You show it in 2 steps. So this amounts to 1 plus the natural log of 2.5. Right? Okay. This one required product rule, but also required you to do a little bit of verbal connection. The region of xi is where the function has positive slope. A function has positive slope, and what happens? Here's the function, here's a function. When it has positive slope, well, the tangent slope is given by the what? What tells me the tangent slope? Okay, what tells me the tangent slope? The derivative, okay. So if I want to know where it has positive slope, then I want to know where the derivative is positive. You've got to make that connection here. Okay, so we can't find where the derivative is positive until we have the derivative. So we should start by finding the derivative. We have a product there, so we need to use the product rule. Here we go. First stays the same. Boom. What's the derivative of the second? 3x squared plus second stays the same. X cubed times the derivative of the first. What's the derivative of e to the x? E to the x. Cool. Now then, got the derivative. Check. Before you do a sign test, it helps to find the zeros. 0 is the great dividing line between negative and positive, so you then find the zeros. You set it equal to 0 and solve. Now, what algebra? There's a lot of calculus is algebra. So, what algebra would you do to solve this equation? I can sum it up in 3 letters. G, C, yes. Yay, GCF. Okay, so the greatest common factor is we can pull out an e to the x. How many x's can we pull out? X squared. All right, in the first, what's left? 3, and what's left in the second? X equals 0. Great. Now then, as far as zeros, how many zeros are there to this? How many x values will make this 0? Does anything make e to the x 0? No, e to the x cannot equal 0. What about then that would be 0 if x is 0, and that is 0 at x equal -3. Great. We have zeros. Now we can divide all the numbers up into 3 chunks. Those before -3, between -3 and 0, and after 0. They must not be They must have signs in those regions. What about at -5? Well, e to the x is always positive. X squared is always positive. And so it's really just about 3 plus x, positive or negative in that region. Negative. Therefore, an overall negative. From -3 to 0, we're talking positive, positive, but now that guy's positive, positive. And after 0, e to the x is always positive, x squared is always positive, 3 plus x is positive, positive. So to answer the question, where does the graph have positive slope? Finally, the gotcha to it. Positive slope. Would you just say -3 to infinity? No, why not? Okay, actually, now you're talking parentheses brackets, but the endpoints is what you should be talking about. Does it have positive slope, negative slope, or 0 slope in -3? 0. So I don't want to include that, but you're right in saying, what about this guy? Does it have positive slope then? What's the slope at 0? 0. And so does it have positive slope then? No. And so that is wrong. It has positive slope from -3 to 0, stop, then 0 to knock it out, forever after. In other words, you cannot include 0 because the graph does not have positive slope at 0. It needs to be stopped and started right after. You with me? Okay. The lesson today is pretty straightforward. I think you'll see it's easy, but it is the second half of all calculus. You could say that calculus divides into 2 parts, differential calculus and integral calculus. Here we go. The second half of all calculus, indefinite integrals. Hopefully you'll be able to take an antiderivative after I'm done. Here it goes. At all levels of math, including calculus, we have inverses. Inverses undo. So the inverse of addition is subtraction. And if I did an addition problem, I could check it with subtraction. And the inverse of multiplication is division. I could check a multiplication answer by division or vice versa. The inverse of a power is a root. The inverse of exponential is a log. The inverse, not everything has an inverse, by the way. What's the inverse of absolute value? Nothing. Yeah, that doesn't have an inverse. Okay, so not everything has an inverse, by the way. But the inverse of a derivative is an antiderivative. Tell me that name doesn't make sense, huh? Now, that makes a lot of sense, but you will also hear it called an indefinite integral. Okay? An indefinite integral is written this way. That actually looks like an S because it is an S. It's a Roman S. It stands for sum. We'll talk about that later. But integration. So here goes. Joe looked at his calculus homework and saw the derivative was 3x squared. So he doesn't have the book out in front of him. He just saw that the derivative was 3x squared. What was the original problem? Yeah, the original function f of x must have been x cubed. Probably. Maybe. All right, now, I say probably maybe because what about all this stuff? What about x cubed plus 7? What's the derivative? 3x squared. The constant's derivative goes away. What about x cubed minus 7? What's the derivative? 3x squared. The derivative of the constant goes away. What about -2 sine 1 plus x cubed? -2 sine 1. Is it -2 cosine 1 or is it 0, the derivative of it? 0, because -2 sine 1 is a constant, and it also has a 0 derivative, 3x squared. Oops, that's not, oh yeah, that's right, 3x squared. All right, now all 4 of these are different, okay? And yet, they all have the same derivative. All have the same derivative. And that's because, well, when you take derivatives, all of them funnel into the same derivative. When you go backwards, you have to consider that you don't know what constant might have been there. when you undo a derivative, the constant zeroed out, so I don't know if it was a 2 there or a 3 there. I don't know if there was a constant there at all. Maybe there wasn't a constant there at all. Now to do that then, you always add, when you integrate, plus c to represent, there could have been some constant there before I took the derivative. I just don't know what it is. That's called a constant of integration. All right. Now then, what problems will look like here? When they give you this, they'll typically, rather than write it the previous way, okay? The way I wrote this the first time was, the derivative is 3x squared. What's the original problem? That's typically not how it's written. Instead, you'll see an integral. This means, here, the same thing, but with a lot less writing. The derivative is 7x to the 6th. What was the original? Okay. So when you see that indefinite integral, you're putting an antiderivative. Well, when you took a derivative, it reduced the power. So when you undo it, the power will probably get bigger. So what was the original problem? If the derivative was 7x to the 6th, what do you think the original was? X to the 7th, but could there have been a 1 there? X to the 7th plus 1, or 2, or 3. So we don't know what else was there, so we say plus some possible constant. Maybe the constant was 0, but we don't know. Okay, so the antiderivative plus a c. You follow? Okay, so when I say the antiderivative of cosine, that means the derivative is cosine, so what was the original? Sine of x plus c. This says the derivative is e. The original must have been e dx plus a possible constant of integration. And then this was one that's constantly missed for a week or two. The antiderivative of 1 over x. What function gives you that derivative? Natural log of the absolute value of x plus c. The only way you could have got negatives and positives is if there was an absolute value there. All right? Don't forget the absolute value. Otherwise, you just took half of the domain. You just halved the domain. You want to allow for negatives and positives. That's why the absolute value is there. All right. Now, there are some times when you can nail down the constant integration if you're given a little more information. Okay. All right. So, by this, let's go back to a case here. Say I gave you the derivative was 2x. Give me a possible what the function could have been. The original function could have been x squared. Okay? What else could it have been? X squared plus c, 1. It could have been x squared plus 1. It could have been x squared plus 2. It could have been x squared minus 1. It could have been x squared minus 3. So really, when you anti-differentiate, f of x is a whole family of possibilities, all with the same slope ideas. They all have the same derivative attributes, but they have different locations by virtue of the plus c that could have been there, the constant that got removed by the derivative, all right? However, if they give you one more piece of information, they say, all right, the derivative is 2x, and it has to go through this point, well then you can narrow it down to one possibility, not infinitely many. So you'll see then sometimes an initial point given. This is more often called an initial, I spelled initial wrong, sorry, initial condition, or frequently shortened down to initial condition, which is just fun to say. I'm not even sure how to spell initial condition, but initial condition, okay? All right, so say you can figure out exactly which one of those if you're given a function that goes through. So say we had this problem. I gave you that yes, the derivative is 2x, and the original point on the curve, I also tell you that when x is 1, the curve has to go through 7. Now with that, that allows you to find the c. First step is take the antiderivative. Now, we talked about inverses here. Okay, let's say one way to write this. Now, what's the inverse of derivative? Antiderivative. And the antiderivative is this integral idea. So I'm going to integrate both sides. This is really with respect to x. The antiderivative of the derivative is just the function. That Roman S means take the antiderivative. Or what was it before we took the derivative? What is the antiderivative of 2x? X squared plus a c. All right? Now to find that c, we have 3 unknowns there. To find that c, we need 2 of those things given. They're giving us that the function is 7 when x is 1. So where does the 1 go? Where does the 7 go? Is the 7 the function value or the x value? That's the function value. X is 1. And with that, then, it implies that c must have been 6. If it's going to pass through 1, 7, the original function must have been x squared plus 6. That has a derivative of 2x, and it passes through 1, 7. You with me? All right. Let's go to these 3 of your own, and you try them, and then we'll check them in a sec. If you're not with me, or you're not quite sure what I was talking about in this certain point, was I mumbled, or a good job? Let me know. Lay my head in you. I can lay my head on. Oh, there's not a place I could escape you. Your heart won't stop coming after. That's not it. Oh no. Okay, ready? All right, so first take the antiderivative of 1 over x, which is f of x is natural log of the absolute value of x plus a c. All right, so then we substitute in the case of 7 is the function when 1 is the x. What is log of 1? 0. So c is 7, which means the function is 1 over x plus 7. Did you win? Yay. Okay. Antiderivative of negative sine of x. What is the antiderivative of negative sine of x? Okay, what function? Did I make a mistake? Oh, yes, thank you. Sorry. Natural log of the absolute value of x plus 7. Geez Louise, I went back to my derivative. Sorry, thank you, yes. What's the antiderivative of negative sine? Cosine. Plus a c. If I plug in negative 3 and pi, negative 3 is the function value, pi is the x value. That leaves me with the c. What is the antiderivative, or sorry, what is cosine of pi? Negative 1. If I add 1 over, then c is negative 2 or negative 4? Negative 2. So f of x is cosine of x minus 2. Now, I could, in all of these cases, take derivatives to check them. What's the derivative of natural log of x plus 7? 1 over x. What's the derivative of cosine of x? Negative sine of x. Okay, so it's easy to check these. Just would that work if I took the derivative of my work? This one is a bit of a gotcha, but hopefully it looks familiar. We've done that derivative a lot. What is that the derivative of? Square root of x. Yeah, that's what happens when we take the derivative of the square root of x. Hopefully you've seen that enough and you remember that. All right, if I plug in 7 is the square root of 25 plus c, then c is 7 minus 5 or 2, and therefore f of x is the square root of x plus 2, and again I can check that with the derivative. All right, how's this going? Are you with me?
Yes.
All right, is there anything more on that sheet?
Yeah,
Oh, super. Try that one. It's an AP question that you should be able to do. We've talked about this a lot, but there are 45 multiple choice questions on the AP exam and 6 free responses. About an hour and a half for each part. Calculator and no calculator for each part, so there's actually 4 parts to it. Whole clear integrating, you're given a derivative, so you anti-differentiate. Derivative is the noun, differentiate is the verb of taking a derivative. All right, ready? Or not yet? Yes? Okay, what do you say? A, B, C, D, or E? Tell me right away, just test strategy. I haven't even done the problem yet. What choices can be eliminated just like that? D is gone. Why? What's the derivative of negative x cubed? Negative 3x squared. Is that the derivative? No, that can't be it. Can't be it. Okay? What about this? So what's the derivative of that? 3x squared. Can that be it? Nope. How about this? What's the derivative of that? 3x squared minus 1, that's in. 3x squared minus 1, that's in. So both of those at least fit the derivative rule. How could you then further choose between those two? Yeah, plug in the x and y and see which one satisfies. And that, you can actually do this by doing derivatives, not antiderivatives. And that works really pretty fast. If you were to do this in an antiderivative way, what is the antiderivative of 3x squared? And the antiderivative of negative 1? Negative x plus a c. And then if they ask you to put that condition in, you'd get something like negative 1 equals c. So your equation must be x cubed minus x minus 1. The answer is b. Okay? So you can do that by test strategy, derivatives or antiderivatives. Good enough. All right. Let's see. Homeworks. Do you still, some of you still have the fun sheet, yes? I just want to talk a little bit about the back, just because there's a big idea of calculus called curve sketching that I wanted you to think about on this homework, but then I didn't ever even talk about it. So, if you turned it in, fine. But if you still have it, let's talk about it. Won't stop coming after me. Okay. Boom. Okay. Now, for those of you who have seen calculus before, this was probably pretty easy. But those of you who haven't, there's just a little school of thought here that'll get you going. Remember, derivatives mean slope, and so it helps to look at zero slopes. Match the functions in a through d with their derivatives in 1 through 3. Note that 2 of the functions have the same derivative. Explain why. All right, now check this out. I would find on the original function where on f, find where the slope is flat. So for example, this guy, the slope is flat there. Well, if the slope is flat, then the derivative is 0 there. This guy has exactly one slope that's flat, so it should have exactly 1 0. Now this has no zeros, this has 2 zeros, this has 1 0. So just by 0 slopes, I know that's the 1. I could also say it has positive slopes before, which makes sense. These are positive values. Negative slopes after, that makes sense. These are negative values, and 0 slope there. This one then is 3. This guy, how many times does it have 0 slope? Does it ever have a horizontal tangent? No, the slope is constantly the same. And if the slope is constantly the same, then that is this guy. This slope is constant. This slope is always up 2 over 1 or whatever. And so this slope is always 2. B is 1. C, how many places does the slope go flat? The tangent slope go flat? 1, 2. Okay? It must have 2 places where the derivative is 0. The derivative is 0 twice. Now graphically then, that would mean the derivative crosses the x-axis twice. That guy must be 2. And last but not least, this guy has exactly 1 flat spot. This then has only 1 0. This is 3 also. Then the other question is, why do these have the same derivative? Why do these have the same derivative? They're different by a constant. They're different by a constant. It's a shift up by 1, and that derivative would totally cancel out that constant. And so these guys, like we talked about today, could totally have the same derivative because they're different just by virtue of a vertical shifting constant, which would go away with the derivative anyway. Right? This one is tough. Let's see here. I'm going to sketch on top of, this is f. I'm going to sketch f prime. Let's go from 0 to 3. What's the slope? 0. All right, so the slope's going to be 0 there. Doesn't really have a sign. I don't know what to make of the slope there, so I'm just going to call it an empty circle. What about the slope here? It's constantly up 1 over 2. Well, if the slope is up 1 over 2, then the derivative is 1/2. All right? Then this guy, this one's hard. This slope, gosh, I don't know exactly what that slope is. It's kind of curving, so it's constantly changing. But it feels like, at least for the time being, that slope is ballpark of about 2 at the starting point. You with me? What happens to the slopes as we go further and further to the right? Yeah, they get less and less until they get horizontal. Now, when the function goes horizontal, the derivative is 0. So at this point, the derivative should be 0, and the slopes went steep to less and less steep, which would mean the slope is smaller and smaller number. And then after that, the slopes go negative. I cannot seem to. So it should be looking like that. Now that actually makes sense. This is negative parabola-ish in nature. So what's the derivative of negative parabola-ish? Negative linear-ish, right? And so this makes a good deal of sense. All right, moving on. This is way too big. I can't see all this together. Your heart won't stop. Okay, last but not least. Match the functions with their derivatives. 1, 2, 3. Let's go with 0 slopes. Graph A. How many 0 slopes does it have? 1, 2, 3. So its derivative must have 3 zeros, or 3 places it crosses the x-axis. Which one of those could it be then? It has to be this guy. This guy matches 3. This guy has exactly 1 place the derivative is 0, and so it should have a derivative with 1, 0. This has 1, 0 slope. Wherever the original function goes flat, the derivative will have an x-intercept. 1 flat spot, 1 x-intercept, they match. This guy has, I know they're tight, but 1, 2 flat spots, and so its derivative must have 2 zeros or 2 x-intercepts. That's there and there. And so that guy is 2. Right? And then the last one, I thought it was worded so badly I wasn't even sure what to do. And I'm a calculus teacher, so I'm not going to even go over it because the wording was terrible. I can show you my answer, but let's not. I don't even want to get into the wording. All right? That's the big idea. Make sure I get that today. And let's go to questions on set 31. Yes? Yes, set 31 still? All right, then. Hit me on 31. 10. Shout them out. Did you say 2? Okay, 2. 1. 6, just kidding. Let me say 12. 12. Okay. 10, 12, 1, 10, 2, 1, 12. Cool. Are these on this class? Or is this something else? I don't know if this is applicable to you. Did I post a key to 31? Are there replacements you need the answers to?
Yes.
Oh, shoot. Are these there?
No. But it would be helpful if you did one of the last replacement.
I will be happy to do so. I
Or
guess.
actually, it's not the last replacement. I'm confused. It doesn't have a number. It doesn't
Okay.
have a number. It just says to replace.
All right, let me dig that up real quick. Sorry. Is it this? That's there, right? So these are the ones. What the heck? Okay, sorry. So you need these two? Hang it.
That would be so fun. I would die.
And they'll go on like an and then together too.
Like a whole story. Oh my god. I don't want to touch
And then
it.
like do like a women's march.
All right. Okay. So, sorry, I'm all over the place here. I thought I posted the key. I apologize. Okay, so check your answer for number 6. Do you have, first of all, the point 0, what, 1? Do you agree with the point 0, 1? Okay, the derivative. You're finding the derivative with the slope of the derivative. So first stays the same, derivative of the second, plus second stays the same, derivative of the first. Y prime then at 0 should be 0 plus 1. Did you get 1 for the slope? Okay, the equation of the tangent line is then y minus 1 equals 1 times x minus 0, or some equivalent to it. Okay? All right. Here's your answer to 12. I'm not sure, did number 13 go okay, or do we need to walk through that? All right. What was 12 asking for a tangent line at 8 or something on those lines?
I don't know, it says adjust a window.
Oh, I changed to number 13. So number 12 is find the equation of the tangent line. So 12 is the equation of the tangent line to y equals the cube root of x squared at x equals 8. Okay, so the point is you have x is 8 and y is 4. Yes? All right, the slope, the derivative is, if this is x to the 2/3, then this derivative is 2/3 x to the negative 1/3, or 2 over 3 cube roots of x. The derivative then at 8 would be 2 over 3 times 2, or 1/3. Therefore, your equation of the tangent is y minus 4 equals 1/3 x minus 8. Do you agree with the answer for 12? Okay then, 13, if I'm going to forget the question, it says replace. So use your answer in 12 to estimate 7.8 to the 2/3. Well, rather than put 7.8 into the function, which is ugly, obviously, I'm going to put 7.8 into the tangent line. So yeah, put it in point slope form. Y then is 4 plus 1/3 of 7.8 minus 8, or 4 plus 1/3 of negative 2/10, or 4 minus 1/15. So your answer should be something like 3 and 14/15. Do that right? 1/5, 1/15. Yes. Okay. How about 14? How'd 14 go? Easy. Good. When the radius is always equal to the height, and the radius increases by 20 as differentials to estimate the corresponding change in volume. Okay. First, volume of a cone is 1/3 pi r squared h. But if the radius and the height are equal, then I could change this to pi over 3r, or 3r cubed. R and h are equal, so in place of h, we're going to put in an r, which gives us 1/3 pi r cubed, or if you like, 1/3 pi can be combined with pi over 3. Check. dv then should be v prime dr. What is v prime? If I leave the pi over 3 and I take the derivative on r cubed, what is it? 3r squared at the previous point. Now the previous point was an r of 20. dr is by how much the radius will change. One instant, oh sorry, never mind, not 20. At one instant the radius was 3 meters, yeah? Sorry. The radius is 3 meters. The radius increases by 20 centimeters. Now we have a little bit of a unit problem here. We need to be consistent. So if I'm using meters there, and I need to make 20 centimeters meters. 20 centimeters is how many meters? 0.02 or 0.2? 0.2. 20 centimeters is 20 hundredths of a meter, yeah?
But that's not what it says right
Oh,
there.
oh, so you're saying the mistake is my mistake.
Yeah.
Yeah, you're right. Hi, Alan. Can you list for your test? I haven't looked at her email yet, but if she said it's cool, then it's cool. That's a really, no, that one. Yeah. Sorry, dude. Very small. Okay, so, wow, my bad. Sorry, Lainey, then I assumed you didn't know how to convert centimeters into meters, but it turns out that's
what
me.
you said.
Yeah, no, I'm just dumb. 20 centimeters is 0.2 meters, not 0.02 meters. All right, so that should be 0.2. I apologize if that was your problem or your question, then that's because I'm dumb. 9 pi times 0.2 then is 1.8 pi, and the units would be error in volume, so meters cubed. Okay? All right. This, I think it says 2 in place, but it's actually on the back side, isn't it?
Yeah.
All right, so by definition of continuity, quality of work, focus on quality of work. The limit as x goes to -2 from the left would be x squared minus x. The limit as x goes to -2 from the right is -x plus 4, and that needs to equal the point itself, which is f at -2. As x goes to -2 from the left, what does that function approach? 4 minus -2, or 6. This guy, as x goes to -2 from the other side, -2 plus 4 is 6. And f of -2, is f of -2 defined? Do they tell you when x is -2 what to do? And the answer is yes, that's like that. And so it is defined. And so all are said, so all the same, so we say f is continuous at x equal -2. Okay?
But it says,
Oh. Apparently, I don't know if that's my intention. Was that my intention? Oh, I know, it's your stupid. Is it continuous at, that's all great practice, but it wasn't the question. Is it continuous at x equal 4? Well, that's this function. Is the linear function continuous? Yes, no? Yeah, -x plus 4 is continuous at x equal 4. So that's actually a non-question. I'm not sure what I was getting at there. Lady, you are a real critical reader. Good job.
I just say figure out.
Oh, there you go. That's, it's, I don't know if it's a trick question or
I was like, I could
what my intention was. All right, 22. Given f, sketch 1 over f, and then f prime. 1 over f is the idea that where this guy is 0, we'll have 1 over 0 for the reciprocal, so vertical asymptotes at -2 and 2. Okay? On this side, these are negative slopes, so the reciprocal will also be, these are positive values, so the reciprocal will also be positive values. But if these are fairly small, then this guy will get fairly big. And so these will be very, very large. And then these will be like reciprocal of, you know, maybe 1-ish or so. And so that'll be something like that, yeah? In here, negatives, reciprocal will still be negative. What's this, instead of a min at -4, we'll have a max at reciprocals, -1/4. Okay? The reciprocal of -4 is -1/4. The greatest possible, or the least possible value will be, and the original is x greatest, so it'll look like that, and then again like that. Okay? So if you're in the right ballpark there. What about f prime? Let's talk zero slopes. This guy has a zero slope right there. So the derivative must be 0. These slopes, are they negative or positive? Negative, okay? Negative. So they're going to be negative slopes. So it's the derivative is negative f prime. So I'm down here. What about here? What is this slope? Ballpark. I mean, is it a fairly flat slope or a very steep slope? Flat. So should the slope numerically be close to 0 or a big number? All right. So over here it should be close to 0 but negative. So I'm thinking like this. Now, as we get here, they get steeper and steeper and steeper. So the slopes should get negatively bigger and bigger and bigger. But then what happens is we get closer and closer to 0. They start getting closer to
Good morning, Devlin Jaguars.
flat.
Please rise for the Pledge of Allegiance.
All right.
Begin.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands,
One nation under God, indivisible, with liberty and justice for all. Please be seated.
These then start going small positives,
Today,
bigger and bigger positives, smaller and smaller positives.
Fuller, please report to the auditorium for the anti-bullying seminar during
That was
step
tough.
Tomorrow, last names Gardner to Lucero. See Mr. Northway if you have any questions.
Okay. 10.
The September Scholars of the Month were selected by the Math Department and are as follows. The Senior High Female Scholar of the Month is Kaylee Lanigan. Kaylee approaches her education with admirable work ethic. She completes every problem. Every problem of her problem set on time. With great attention to detail and showing her work. Kaylee often comes in during 7th hour or before school to ask questions, making sure she understands those problems. She truly embodies our Devlin values of honesty, integrity, respect, and responsibility.
Thank you.
Senior High Male Scholar of the Month, Alex Mutai. Alex is the MVP of Mr. Group's Big Power BT Test course. He enthusiastically tries problems he has never seen before and is the leader of the class position with his questions and responses. In short, Alex is an amazing student of the calculus.
The Junior High Female
Darn it.
Scholar,
Sorry.
Lily works diligently each and every day, taking time to make corrections on all her
Dang
problems.
it.
That she ensures she knows how to work every single problem on every single set. Her effort has resulted in grades of an A on each for 2 tests.
Okay, sorry.
Devin has demonstrated
All right, let's start with this. The period, is it normally 2 pi or pi? For tangent, it's pi. So the period of this is 8. That would mean that a tangent curve
Interested in driving?
goes from -4
Stop by at
to +4 for the asymptotes for a total period of 8, yeah?
the first
So I would go by 1.
interest meeting is Wednesday, September 19th at 6 p.m. in the Bear Creek Lecture Hall.
The 0 is unaffected, it's still 0. But this guy, which would be a 2, would actually be stretched to 3. So -2 is -3.
There are various upcoming college information nights not at Devlin for students and parents who want more information. Check the See What's Happening bulletin board by the cafeteria.
Make sure you go for the entire space provided.
University of Virginia, Princeton, USC at Berkeley, Dartmouth, Brown, Cornell, Columbia, and more.
Senior high students. Students receive an academic letter for earning a grade point
How's
average
that?
of 3.5 or higher during the fall and spring semester of the
2.
If you accomplish this, your name should appear on one of the
Darn
documents
it.
hanging on the front door.
Whoa.
It's different from the honor roll, which is earned for one semester
Whoa.
or higher GPA. Please let Mr. Kotkins know if you earned an academic letter, but your name does not appear on the list, so we can correct for the awards ceremony program.
Seniors, another reminder, this Friday is the last day to submit baby pictures. Stay true to tradition and submit them via the yearbook button on the Devlin homepage. Submit your pics or be sad and cry. Laughing.
Wow.
That's all your announcements. Have a great day.
Okay, 2. 2 still a question? Can I do 2? Do you need 2? Okay. Darn it. All right. I'll put those 3. This time I really want to remember. I'll put those 3 on the website, 2, 1, and 12. And I'll put them on the set 31 day in the calendar. Any questions? Sorry. I should have had my key on mine, I guess that's my
Probably
fault.
broken. Probably ripped off.
All right. Have fun?
Did Emma tell you that you guys take a home tonight?
Yes. But she's taking the home, I'm staying on after you guys can leave. You can go with Harper. Okay? You lost your phone? Hi.
I've done this problem like 4 times.
This one?
Yeah.
Yep.
And every time I take the derivative, like,
So it's the algebra that's an issue. So this is what I would suggest. First, if you write it this way, negative 1 over x to the 3 halves plus 3 over x to the 7. Looks like they got a common denominator. So in getting a common denominator, it would help you to write this as 4. So negative 1 over x to the 6 4 plus 3 over x to the 7 4. That then means the common denominator is actually 7 4. If you got the next by this by an x to the 1 4. That will get you the answer. Okay? What? Do I have any questions? Oh, yeah, on the back bulletin board.